Conditional distribution. So let us try to understand conditional distribution with the help of a simple example. Suppose you're a traffic police officer and you are trying to find out what is the extent of individual injury in automobile accident in case if they were wearing no restraint, or there was a safety measure in the form of a belt, or they were having one more safety measure in the form of a harness. So harness is the kind of the safety measure which will help you which will protect you from falling, right? So that's an extra safety measure. So you may have no restraint, you may be wearing just belt as a safety measure, or you may be wearing one extra measure of safety, which is harness. Injury could also be categorized into several categories. For example, you may have no injury at all. You may have a minor injury. You may have a major injury, or they can be a death. Now, you as a police officer, you are trying to find out that, okay, there was no injury, but what is the probability that the person was wearing only belt as a safety measure? Okay, there was a death, but what was the probability that he was actually wearing both belt and harness? So this is conditional upon something. So that's a kind of the conditional probability. Now here what we have done is that, let's say we've taken one sample of 100 people. And we have collected these sample of 100 people, sample of, let's say, these 100 accidents which have happened. And you found that in 6 accidents, there was no injury, and the person was also wearing no restraint, no safety measure. In 7 of such incidents, there was no injury, and the person was wearing only belt as a safety measure. While in 7 of such incidents, there was no injury, but the person was wearing both belt and harness. So in how many cases there was no injury out of 100? Although there was an accident, but there was no injury. That no injury can come from the cases of no restraint taken up, only belt and harness. So there were 20 such cases. You've just added them up. Similarly, let's say, what about this? So in 10 such incidents, what happens is that there was a major injury and person was wearing only belt as a safety measure, right? How do you interpret this 5? In 5 incidents, there was death. In 5 incidents out of 100, there was death, right? Now that can of course come from he was wearing no restraint, no safety measure, or he was wearing only one safety measure, or belt and harness both. How do you interpret this 35? Right? How do you interpret this? 35? 35 means out of those 100 incidents, there were 35 such incidents in which person was wearing only one safety measure, which was belt. Right? There can be the cases that there was no injury, minor injury, major injury, or death, but the person was wearing only person was wearing only belt as a safety measure. I hope you understood the table. Let us convert this table in terms of probability. right? Let us convert this table in terms of probability. So there were how many cases? 100 cases, na? So in 6 out of 100 cases, you had this guy. Person was having no injury and person was wearing no restraint. In 7 out of 100, person was having no injury and person was wearing only belt as a safety measure. In 7 out of 100 cases, person was having no injury and person was wearing both belt and harness. So adding them up, in 20 out of such 100 incidents, there was no injury, right? Similarly, we can fill up the other numbers also, right? So let me just fill that up quickly. I can also just copy it down, no? Be easier for me if you allow me. I just copy it down and I'll just put 100 divided by 100 divided by 100 divided by 100. So it is like this. Amita. So how do you interpret this guy? In 12 out of 100 such cases, there was a minor injury, but person was wearing belt and harness both. So the probability of the minor injury is what? 17 by 100 plus 16 by 100 plus 12 by 100. That gives you 45 by 100. What about 10 by 100? How do you interpret this? In 10 out of 100 such cases, person had major injury and he was wearing only belt as a safety measure. So the probability of having the major injury is what? 13 by 100 plus 10 by 100 plus 7 by 100. And this gives you 30 by 100. Right, similarly here. And in 1 out of 100 case, there was a death, although the person was wearing both belt and harness as a safety measure. So the probability of death in these cases is what? 5 by 100. And you add all of them, 20 by 100 plus 45 by 100 plus 30 by 100 plus 5 by 100. And this gives you 100 by 100, which is 1. Right, which is 1. What about this? The probability that there was probability of the incidents when person was wearing no restraint, no safety measure. 6 by 100 plus 17 by 100 plus 13 by 100 plus 2 by 100. And this gives you what? 38 by 100. Similarly, this 35 by 100. And this gives you what? 27 by 100. So in 27 out of 100 cases, right, person was wearing belt and harness both as a safety measure. And you add them up, you get 1, right? You add them up, what you get is 1. So what do we have out here? What do we have out there? So this is what is it that we have found out, right? This is the two-way table of joint probabilities. And we have been talking about joint probabilities since last 2 or 3 recordings. Okay. Up until now, note that we haven't come over to the conditional probability, right? Although I've given you roughly something about the conditional probability, but we'll be defining it using an example. What is the probability that a randomly selected person in an automobile accident was wearing a seat belt only and had only a minor injury? So there are two events. There are two events out here. So one event is that event A is that person was wearing seat belt only. Right? and B is that randomly selected person was had only a minor injury, right? So person had a minor injury. You know what? I should be writing this minor injury thing as A and this is as B, because I have written extent of injury as X and restraint as Y, right? So I am writing it this way because I have written this guy extent of injury as X and restraint as Y, although it doesn't matter here. Okay, so the probability of A intersection B, think about it. The person was wearing only belt and he had a minor injury. This is what 16 by 100, right? This is what 16 by 100. This is what 16 by 100. Okay. So now come to this example. Now here we are interested in subpopulation of the overall population in the conditional probability distribution. So the conditional probability distribution, what do you mean by this is that is the probability distribution of the subpopulation. That is, a conditional probability distribution describes the probability that the randomly selected person from a subpopulation has one characteristic of interest. What do you mean by this? What do you mean by this? What is it that we have said? So we'll come back to the definition. Let's look at one example first. If a randomly selected person wears no restraint, what is the probability of death? If the randomly selected person wears no restraint, what is the probability of death, right? So how do you define this? That is, you will be saying that what is going to be your subpopulation? Subpopulation is population of people wearing no restraint. Right? And the characteristic of interest is death. And the characteristic of interest is death, right? So what is it that we are interested in this? This is the subpopulation. Right? And this is the characteristic which we have. This is the characteristic which we have. So they're intersecting somewhere here. So what you are trying to say is this. So how many people were wearing no restraint? 38 upon 100. What is the probability that people were wearing no restraint? It's 38 by 100. What is the probability that people who were wearing no restraint, they had death? That is 2 by 100. Right? So the characteristic is death, and the population and the subpopulation is wearing no restraint. So what you say is that we are interested in finding out the probability of death given that people wear no restraint. That is this. So probability that people are wearing no restraint and they have death, right? Given that that they were wearing no restraint, that's what your conditional probability is. So what is it that we need to find out? When x is 3 and y is 0, that intersection upon probability that y is 0, right? So probability that x is 3 and y is 0 upon the probability that y is 0. Upon the probability that y is 0. So probability that this thing, x is 3 and y is 0 is what? 2 upon 100. Probability that y is 0 is what? 38 by 100. So it is 2 upon 38, which is 1 upon 19. So one more thing which you have to understand from this is, we are trying to find out that probability is x equals to small x. In our case, x equals to 3, right? That is death happens. Given that y equals to y, given y equals to y, given this y equals to 0, for each element, not just for one element, right? Not just for one element. So what we are trying to find out is probability that the death is going to occur, right, given that people do not wear restraint. Given that people do not wear any restraint. So we are not just finding out this probability. So it is not just finding out the probability of x equals to 3 and y equals to 0. We are finding out the probability of x equals to 3 given this thing. Not just one element. Not just one element. Not for each element in support S, not just for one element. That's an idea. So how do we write the conditional probability mass function of x? Is we write it like this: gx given y is this joint probability upon this marginal density, provided this is greater than 0. Of course, this is, right? So that's an idea. This is the way you define the conditional probability mass function of x given y equals to y. Let's look at one more example. If a randomly selected person sustains no injury, if a randomly selected person sustains no injury, then what is the probability that he was wearing no restraints? That he was wearing no restraints. Okay, so how do we write this? What is the subpopulation here? that population of people having no injury or sustaining no injury. And what is the characteristic of interest? No restraint. Characteristic of interest is no restraint. So what is it that you want to find out? So you need to find out this, that the subpopulation is this guy. This one. So basically this. So the probability that people had no injury is this, right? People had no injury is this. And the characteristic of interest is this, that no restraint. So it is going to be what? Your this intersection upon this guy. So it is 6 by 100 upon 20 by 100. That's an idea. So how do we write this? We write it like this: probability of no restraint given that they had no injury. Right. So no restraint is what? X is 0. Sorry, no restraint is what? Your Y is 0, and no injury is what? X is 0. Huh? Huh? No injury is what? X is 0, and no restraint is what? Y is 0. So X is 0, Y is 0, and no injury is what? X is 0. Beta. So how do we write this? So this is going to be what? 6 upon 100, this guy, upon 20 upon 100. That means 6 upon 20. That means your 2 upon 10 on this guy. Sorry, 3 upon. I'm so sorry, 3 upon 10. Okay, 3 upon 10, right? So again, in order to find the probability that y equals to capital Y, given x equals to small x, we are interested in finding out that, not just for one element, not just for this. So given this thing is there, given x is equal to no injury, we're not just finding out the probability of this intersection. So how do you write the conditional probability mass function for this? You write the joint probability upon this marginal one, fx x, provided fx x greater than 0. Right? I hope this thing is clear, beta, about the intuition behind the conditional distribution. The intuition behind the conditional distribution, right? Okay. Thank you.